In this module, we will look at the Flight Director System. We will start with a brief overview, then we will look at the controls and indicators, followed by a discussion of the various Flight Director modes. We will also look at command speed limiting functions. We will look at an overview of the Flight Director System. The Autopilot and Flight Director are basically one system. In addition to providing autopilot commands, the flight control computers, or FCCs, also position command bars. The autopilot and flight director can be used together or separately. Unlike the autopilot, the flight directors can provide takeoff guidance. The autopilots have a landing flare capability, while the flight directors do not. The flight director bars retract from view at 50 feet radio altitude during an ILS approach. If only one flight director is engaged, the command bars are driven by their respective FCC. FCC-A drives the captain's command bars. FCC-B drives the first officer's command bars. When both flight directors are on, both flight directors are controlled by the master FCC. The master FCC is determined by the following logic. If neither autopilot is engaged in the command mode, the first flight director that is turned on will make its associated FCC the master. If either autopilot is engaged, the FCC associated with the first autopilot engaged becomes the master, regardless of which flight director was turned on first. When the flight directors are turned on and no autopilot command modes are engaged, the command bars will be out of view until a mode is selected. The FD annunciation appears when either flight director is on and the autopilots are off or in the control wheel steering mode. If a flight director is turned on in flight while an autopilot is operating, the flight director operates in the same mode as the autopilot. Let's take a look at the controls and indicators associated with the Flight Director System. The controls and indicators for the Flight Director System are located on the left and right side of the Mode Control panel. The autopilot controls and indicators are located on the right. The flight directors are controlled by two on-off switches, one for each pilot. They are located on the left and right side of the Mode Control panel. The master, or MA light, illuminates to indicate that the associated flight control computer is the master computer. The master computer operates in the mode selected on the Mode Control panel. The master computer relays these modes to the other FCC. Each FCC drives its respective command bars and mode annunciator. When an autopilot is engaged in CMD mode, the associated flight control computer becomes the master and the associated MA light illuminates. During a flight director only takeoff or go around below 400 feet radio altitude, or during an ILS approach with localizer and glide slope captured, neither flight control computer is the master. In any of these cases, both flight control computers provide guidance based on the settings on the Mode Control panel, and both MA lights are illuminated. When operating in the approach or VOR localizer mode, it's important to be aware of which flight control computer is the master. In this example, the captain's flight director is the master and he is using it to track inbound on a radial. At the same time, the first officer has tuned a different VOR to identify an intersection. Because the captain's flight director is the master and it is engaged in VOR localizer, the first officer's flight director is also engaged in VOR localizer and gives the command to turn right. In this configuration, the first officer's roll commands should be ignored. The flight director command bars can be used for guidance while operating the autopilot in the control wheel steering mode. The flight director as well as the control wheel steering modes are enunciated in the FMA. Let's look at the flight director modes. All of the autopilot modes are also flight director modes. They are engaged and operated in the same manner as for the autopilot. Unlike the autopilot, the flight director has a takeoff mode. Let's take a look at the flight director takeoff mode. When the takeoff mode is engaged, N1 is enunciated for the auto throttle, and TOGA is enunciated for pitch and flight director for autopilot status. The flight director command bars appear and command 10 degrees nose down until 60 knots. The flight director will command wing level, but no roll mode is enunciated. At 60 knots, the flight directors will command a pitch of 15 degrees nose up. This is not a rotation command, but represents the correct pitch attitude after liftoff. The flight directors will continue to command a wing level attitude. During liftoff, the flight director will continue to command 15 degrees nose up until a sufficient climb rate is achieved. The flight directors will then command a pitch to maintain the airspeed set in the mode control panel plus 20 knots. Normally, V2 is set in the mode control panel for takeoff. Therefore, the flight directors will command a pitch attitude to maintain V2 plus 20 knots. In the takeoff mode, the roll mode will command a wing level condition. If an engine fails during takeoff, the flight directors will command the pitch to maintain the greater of V2 or existing speed. However, if existing speed is greater than V2 plus 20 knots, the flight directors will command the pitch to maintain V2 plus 20 knots. Below 400 feet radio altitude, no other flight director modes are available. To terminate the takeoff mode below 400 feet, both flight directors must be turned off. Above 400 feet, any other pitch or roll may be selected. However, change in pitch will terminate the takeoff mode. With the flight director still engaged in the takeoff mode, selecting an autopilot automatically engages the level change mode for pitch and the heading select mode for roll. The AFDS annunciation of takeoff automatically changes to heading select and MPC speed. The flight directors can engage in the takeoff mode even if the flight director switches are off. The flight director command bars automatically appear on both EADIs if a TOGA switch is pressed after 80 knots but before 200 feet AGL is reached and prior to 150 seconds after liftoff. The other mode of the flight director is the go-around mode. The go-around mode is available anytime the aircraft is below 2,000 feet radio altitude with both flight director switches on. To engage the go-around mode, press either TOGA switch while the aircraft is below 2,000 feet radio altitude. After engaging in go-around, the command bars appear for both pilots. When the go-around mode is engaged, TOGA is enunciated as the flight director pitch mode. The IAS Mach display blanks, and the airspeed cursor points to the maneuvering speed for the flap setting. During a two-engine go-around, the flight director commands a 15 degrees nose-up pitch. Roll commands will maintain the existing ground track at the time of a go-around engagement. After reaching a certain rate of climb, the flight directors will command pitch to maintain the maneuvering airspeed for the existing flap setting. During a single-engine go-around, the flight director pitch commands 13 degrees nose up. As the climb rate increases, the flight director commands a pitch to maintain a certain target airspeed. If an engine fails before 10 seconds have elapsed since the go-around engagement, the flight director will command a pitch to maintain the speed set in the MCP. If an engine fails after 10 seconds have elapsed, the speed that existed at go-around engagement becomes the target airspeed. However, if the speed at engine failure is more than 5 knots above the go-around speed, the current airspeed is maintained. In either case, the go-around target speed is not less than the V2 speed for the flap setting, except in wind shear conditions. Now we will look at command limiting and performance reversion. The Autoflight system provides both command limiting and automatic reversion to prevent some limits from being exceeded. With gear or flaps extended, selecting an airspeed above the applicable placard speed, the AFS will allow acceleration up to the placard limit. If an airspeed below a minimum is selected, the AFS will allow deceleration up to the minimum speed. Minimum speeds are approximately 1.3 Vs for the current flap configuration, which is based on the angle of attack. When approaching the gear or flap limit speed, the overspeed or underspeed indication will flash in the MCP IAS Mach window. This indicates that a limit is being approached. The underspeed indication is a flashing alpha symbol, and the overspeed indication is a flashing full 7 segment symbol. An airspeed higher than VMO or MMO cannot be selected in the IAS Mach window. The AFS will never command an airspeed greater than VMO or MMO. If the airspeed exceeds VMO or MMO, the overspeed symbol will flash to indicate this condition. Now let's look at performance limit reversion. When operating in the vertical speed mode, if actual airspeed becomes more than 5 knots less than the MCP selected airspeed and there is no acceleration, the AFS will automatically revert to the level change mode and the underspeed symbol will flash. The AFS also provides a limit on the minimum speed which can be commanded. This speed is 1.3 times the stall speed for the flap setting and is based on the maximum permissible angle of attack. When too low an airspeed has been selected and the actual airspeed approaches the minimum airspeed limit, the flashing underspeed symbol appears in the IAS window. The autopilot will revert to the level change mode and hold the airspeed at 5 knots greater than the minimum speed value until a higher airspeed is selected. Minimum speed protection is not available if the auto throttle is off and the autopilot is in altitude hold mode or after glide slope capture. This concludes the presentation on the Flight Director System.